Okay, let's take a look at problem 7.9, millimeters, grams, and seconds. Part's origin and location is indicated in red, so center and bottom face. Part is symmetric, and lines, circles, center lines, rectangles, extrude boss, extrude cuts, fillets, chamfers, and mirror. Okay, so let's go ahead. Based on our geometry, we're going to be in the top plane. So we'll open up the sketch, get our geometry. Let's see, does that need to be, well, it might be better to be a revolve, huh? Yeah, just kind of should have scrolled down a little bit more. Yeah, so I think I could probably do this profile about as fast as stacking that up. So let's just Control Z, make sure I'm in there. Control Z. Let's look at the front plane, and with a revolve, we'll go center line, vertical, infinite length. And let's use the S key, so we'll have the line. We'll go up, over, back. Should be vertical to the outside. Once we remove that little bit of a flat, we'll see that notch. It's not going to be interior or exterior of the part until we create it. All right, our overall height is 30. And our inside diameter is 47. Then the outside is 55. All right, another interior diameter we called out is 30. Okay, and then we just need the height. Let's go with, so the step was 6 and 5. So probably didn't really need to do the 30 if we're going to stop at that flange. So let's go 24 here. And then that gives us a thickness. Am I reading that right now? It's to the flange. So they did a bunch of strange things there. All right, so I'm going to go back to 30 and I'm going to start center lining it to get my numbers figured out. All right, so they gave us 6. That will be to the top of the flange. From there, we'll go 5. And then the step is actually 1 above that. So I want to make sure I'm reading all of that stack up correctly since we don't have a direct number. So we'll go back to 1. All right, and then so I'm going to do a split entities so that I don't lose my geometry, but this will let me convert to center lines because I don't really need this, or this to be object lines. We'll just make that the construction line. All right, so I think I've got that deciphered pretty well. And I'm just going to take one more quick look at the stack up. So 6 from that face to that face, 5 from that face to that face, and then the inside of that is 1 up. All right, so design for convenience and detail for manufacture. I would not do this in the manufacturer. You're going to have some pissed off machinists. Let's go ahead with our axis of revolution and go that way. We'll open up the sketch. We're going to mirror, so could be infinite length, or we can just go corner to corner. Let's see, is it going to be, yeah, probably going to need another center line, whichever side we draw on. I want to convert, because that is going to take place. Let's see, the inside is tangent, so let's just go ahead and generate that and mirror it. And we'll go into our dimension, set the angle. We are given an angle of 100 degrees. And let's see, what do we have? Do we have a distance overall? I guess it's just going to come back to the tangency. So let's go from there to there and make sure that we got both of those. And then that arc and that circle will be tangent. And what else? How is this able to move? All right, so the inside, I am not seeing that that radius. So diameter of 5 typical. Is there something in the detail? So if they did diameter of 5, maybe we'll go radius of 5 and see what that looks like. All right, and then we're going to take these, but I only want the geometry. Oh, so one of the things that happens with the shaded sketch is it thinks I'm selecting that shaded contour. So if I turn off the shaded portion, I can just get those. All right, so turn off shaded sketch contours, and then it'll let me window pick from left to right. I probably could have come all the way out here and got it, but I didn't want to. We're going to go ahead and mirror. And then I can turn the contours back on if they are usable. Oh, well, I guess if that was concentric, let's go ahead and switch that over to a driven dimension. Let's see, I need to get back into my smart dimension and make that 5. And then if those are actually concentric, yeah, it looks pretty good. So that may have been the stack up. Well, let's make sure I'm in smart dimension. And I know we have a dimension for 37. And we'll set those two to equal. All right. Okay, another quick look, and then that ended up being 3.5. So as long as those are concentric, then yeah, we're good. Okay, so let's go ahead and show the revolve sketch because I would like to use my vertex. We're going to pick that one and that one. And no, it is not midplane. We're just going to go up to vertex. And I'm going to identify that. So if there is a change, I'm going back to that first sketch to generate that, that geometry. All right, so since we're here, we'll go ahead and pick that sketch and it becomes the extruded cut. And I need the geometry to be up to next. And we'll go there and there to complete it. Okay, so the through geometry goes that way. Going back to the top, just checking to see if there's any fillets or radiuses there. So I'm just going to do rectangle, select the midpoint, and we also could have gone onto the front plane and generated that geometry as well. Okay, so that becomes coincident. And we're not really set for the width. No, we didn't really get a width, so yeah, that probably would have been better to do on the front plane. So that one I am just going to go ahead and discard. And plan B, we go to the front plane. And I think this will have a little bit better on the geometry. And if I'd drawn it over here, I would be right to that sketch, but we can make that collinear. And then what do we have for the depth? 5 typical. No, that's to the bottom of the hole. Oh, it was 10. Whoops. So I got ahead of myself there, second guessed myself, and I just needed to look at the sketch a little bit better. So let's see what the edit sketch looks like. All right, well let's go this way. And we can select midpoint, horizontal, select midpoint, horizontal. We'll go collinear. We need to bring one of those up to be coincident. And typically I will just put a dimension there rather than trying to figure out, because occasionally tangency will generate that that body, and I don't know that that is what I want it to do. So let's go ahead and make those equal. All right, so I've got the 10 millimeter wide. It's going up to that that sketch. So if I do the vertex, so the advantage of the vertex is that if there is a change, then these are all in one place and I can kind of see their end result. So let's go ahead with the whole location. We should be able to hide that. And we have a diameter of 4. It is going to be vertical to the origin since we're on center line. And then we need a height from, what are we given? Oh, so the 5, 6, 5, 1. Oh, interesting. So it does look like I made a stack up. So 6 and 5 and 1 back. So 1 to 5, and then oh, so that was the 12 millimeters. All right, so we're gonna see how well I how well I adjusted this. So let's escape out of that. We'll go back into the revolve sketch, and so actually the number becomes a center line here. Just make that coincident because that depth was to 12. Let's see, yeah, 12. So that puts it in a different perspective. All right, so that is the bottom of the flange. It came out to 5, but that one is not there. So I'm going to go ahead and delete that one. One that way, and then, oh, actually, where is that distance from? Okay, so I want that one to be the 5, and we're still, oh, there's my 1, so I should be able to reverse the sense on that. That gives me the distance. All right, so like I said, that was a crazy stack up, so we'll see what that does. And we will show, and then in Sketch 7, I should be able to identify all of that. All right, that's a little hard to see. So that was the top, and I lost one. So that is the 12. And that is, so I got another one in there on 18. All right, well, I definitely messed that one up. So this is where we start out thinking it, we're going to be in trouble. All right, so there it is. We'll drag that one up, change that dimension. If the drag doesn't work, then you're going to have to delete it. And so that builds up that way, that builds up that way. All right, so we came down 12 to that face based on that number. And then the bottom is 1 off of it. So I think I'm just going to be better off deleting some of these, making sure that I get those out of there. And can actually see it. All right. So let's see what my tricks and traps got me from that one. So let's go back into the cut. Make sure that the vertex goes there. And we'll update. All right, that looks better. And then editing sketch 7 puts my center on that sketch. Coincident. Okay, and that makes sense because it is in the back. And extrude cut, blind 5 millimeters. And we'll go ahead and accept it. All right, so this that was pretty good. It did throw me a little bit on the stack up, so we need to pay attention to those numbers. Then we'll just go right plane, and nope, need the pull down to mirror, and I can see the preview over there, so that looks pretty good. Let's go back into the shaded. So kind of expecting this number to be all over the place. Chamfers are 1.5. Now it did show a partial there. So that being the case, kind of thinking that before we generated that, we needed to put in the chamfers, although that's not my preference. Let's just put in enough to for what we need. 1 millimeter, go ahead and hit OK. And then pull that down, yep, and then we got the partial. And then where else? So the problem with the 1 millimeter on this inside, or this step, is going to be actually machining it. With the round tools, we'd be able to get close to that edge, but not complete. And we'll stay with the 1 millimeter. All right, quick check since we've got the chamfers on the outside, upper, and interior. All right, P7-9. And we'll save it, and our volume then is 21,908. And we are 21,907, so after all of that, we got pretty close on that one. So